You came across this question in your Jamb exam. How will you solve it? It is very easy. Now let's solve together. The question says, in the electrolysis of dilute sulfuric acid using platinum electrode, the products obtained at the anode and cathode are. Now, this question is extremely very easy. And what we have to do here is to note the topic to which this question is from. And from the look of things, this question is from the topic in chemistry called electrolysis. And it is very, very easy. So before we go ahead to solve this question and determine the answer to this question, because at the end of solving this question, I'm going to give you your own question so you solve and provide the answer in the comment section. So watch closely. So first of all, we have to know what electrolysis is all about before we can go ahead to solve this question. And it is somewhat very easy. So first of all, what is electrolysis? Simple. Electrolysis is simply the passage of direct current. I did not say electrolysis is the passage of alternate current. This is quite different. So electrolysis is the passage of what we call direct current. Please take note, it is the passage, note this, passage of direct current through a compound. This also is very, very important. It is a passage of direct current through a compound in solution or molten state. I'm going to explain further what I mean by what I just said. So for this compound to actually allow this current to pass through it, the compound must be either in two forms. And what I just said, that the compound can be either in molten state and as well can be either in what we call solution form. And I'm going to elaborate more on all of these things, okay? So this first must be noted. Now also, it must be noted here that this process, which is called electrolysis, it occurs in a special vessel called the electrolytic cell. So this must be noted as well. It must be noted here that electrolysis occurs in a special vessel called the what? Electrolytic cell. Now it must be noted here that electrolytic cell is different from another cell called electrochemical cell, because in these cells have their components. Are you there? For electrolytic cell, it has one major component which is called electrodes. Not what I just said. Electrolytic cell has what we call electrodes. Electrodes are the terminals in a cell to which current passes through. Do you understand? Though it passes through the compound, this compound is found in the container. I'm not talking about the electrolytic cell right now, but we'll be using it to solve this question. So it must be noted here that this electrolytic cell has what we call electrodes. So we build on that. Electrolytic cell has what we call electrodes. And majorly, we have two major electrodes, which are called anode and as well cathode. And I believe you saw that in this question. We'll work on that very soon. So these anode and cathodes are the major electrodes that are found in the electrolytic cell. Though the other cell mentioned earlier called the electrochemical cell also have what we call anode and cathode, also have what we call electrodes. But I'm not talking about that right now, but this must be noted because this alone will help you solve some questions in the Jamb exam. So it must be noted here that in an electrolytic cell, what you are seeing right now, it must be noted here that the anode of an electrolytic cell is positive. This is very important. And as well, the cathode is negative. This is extremely very important. While if I were to talk about the electrochemical cell, the anode, because I told you that that cell also have what we call anode and cathode, but for that cell called electrochemical cell, the anode and cathode, they have different signs, like we just interchange them. For electrochemical, anode now will be negative, where the cathode will be positive. I believe you understand what I just said. It is very easy. So that is for that. We've built on that. So let us progress to solve this question. Now, moving further, because this question is specifically on the aspect of electrolysis called mechanism of electrolysis. I already have full video lessons where I explain electrolysis calculations. That's quite different. This is the theoretical aspect to which questions on electrolysis can be asked. But for the calculations, I already have that on my YouTube channel. So you go check it out and watch those video lessons. It is very, very easy to understand. So moving further, I said that this question is on mechanism of electrolysis. And on this mechanism of electrolysis, it follows three important steps. You know, when we talk about mechanism, it has to do with steps. So, mechanism of electrolysis follows how many steps? Three important steps. Very simple, watch closely. What are these steps? The first step in mechanism of electrolysis starts with what we call ionization. This is very, very important. It is the first step on the mechanism of electrolysis because this is what we need to solve this question. So watch closely. Now, the other step in mechanism of electrolysis is called migration. I believe you are following me. We'll be using all of these things to solve this question very soon. Whereby the last step in the mechanism of electrolysis is called discharge. Discharge, or you can call it preferential discharge. I had to do it this way so that it will be easy for us to understand. So moving further, first, what do? We have to analyze the compound to which was found in the question to which this current passes through. And from the look of things, it was dilute sulfuric acid because they said that in the electrolysis of dilute sulfuric acid. Watch closely. I'm going to write it here. Dilute sulfuric acid. Now, it must be noted here that dilute sulfuric acid, the sulfuric acid itself has its chemical formula to be H2SO4 because I'll be using this to solve this question. It's very important, okay? Dilute H2SO4 is same as dilute sulfuric acid. So they now told us that in the electrolysis of dilute sulfuric acid using what? Platinum electrode. Just take note of this. Sometimes in some question they will give you an electrode that they use during the process, but some electrodes are actually inert. Some electrodes, because we also have different types of electrodes as well, but these are the major types, so don't get confused. We have other electrodes like platinum electrodes, mercury electrode. Mercury electrode has a function, is very, very important in the process of electrolysis. But in this case, using platinum electrode, whenever you see platinum electrode is just there, it is inert. Take note, it is inert. It does not affect the process. It's just used. So this platinum electrode will just get rid of it. We don't have any business with it. That's what I mean by that. So using platinum electrode, the product obtained at the anode and cathode. So at the end of the process, what do we get here? And also what do we get here? That's what the question is asking us. What do we get at the anode and also what do we get at the cathode? That's what the question is all about. And it is very easy. You have to watch closely as I solve this question. Now, moving further, remember I said that electrolysis is the passage of direct current through a compound. This is the compound. The compound in the process can be either in form of solution or molten form. So what's the question? The question now is, what's the form to which this compound is existing? This compound now dilute means this compound has been diluted with water. You understand now? They've diluted this compound H2SO4 with water. So this compound definitely is going to be in the form of a solution. So that tells us that wow, this compound can actually be used in the process electrolysis because it must be either molten or in the form of solution. So this is a solution. So please watch closely. Whenever we have a solution, like whenever you see any question on that aspect, you see that the compound is a solution. That means it's going to be the compound and water. Because this is a solution. Dilute H2SO4 is going to be now, listen carefully, it's going to be H2O and as well the compound which is H2SO4. I believe you are following. It is very, very easy. It's going to be water and H2SO4 because they said it was diluted. Some other time, they might not say diluted, they will just say, the word they will say is H2SO4 solution. When they say that, you know that, wow, that means it is H2SO4 in water. I believe you understand how this was gotten. But for instance, they mentioned using molten H2SO4. Using molten H2SO4, for instance, that's how the question was asked. Is going to be just H2SO4 without water. Water will not be there. This is very, very important. For instance, it was molten. So this also applies for any compound given to you. So watch out for the word molten or the compound being in a solution. If just the solution is going to be in, they are going to write dilute, you understand? So that is for that. So we've seen that this compound dilute H2SO4 is made up of water itself and H2SO4. So moving further, let's run through the mechanism. And the first step on the mechanism of electrolysis is ionization, meaning that all of this we have to form them. We have to make sure that they are in their ionic form. Very easy. So walk through the first, which is ionization. So on the process of ionization is going to be, let's break out this one, which is H2SO4. So breaking out H2SO4 to be its ionic form is going to be a reaction like this. H plus SO4 2 minus. If you don't know this, please know it from now. Whenever you break H2SO4, you are getting H plus SO4 2 minus. These are the ionic form. That's why it's called ionization. Make sure that you break this compound to form ions. That's what they're asking us to do. So the other guy here was H2SO4, so we'll do the same. So you already know that whenever you break water, which is H2SO4, you are getting H plus OH minus. I believe you are following. So we've run through the first step, which is called ionization. Are you following me? It is very, very easy. So for instance, it's just molten H2SO4. There is no need to write for water because molten means there is no water. I believe you are following because this is going to help you greatly in solving other practice questions under the same aspect because they do ask questions under this aspect in the same pattern. So moving further, what's the next step? The next step is migration. What's migration all about? It is very easy. Migration has to do with you making sure that the ions you have gotten, which is H plus, SO4, 2 minus, and OH minus, is migrated to the specific electrodes. Now listen carefully. It's very easy. That's why we built initially that the first electrodes called the anode, they are positive.
To have more understanding about chemistry calculations and solving all of this type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
And the other electrodes called the cathode, they are negative. So we have to know that according to a scientist called Charles D. Augustus Coulomb, he said that like charges, do they attract or repel? Like charges repel. Unlike charges attract. So what does this tell us? Like plus, will they come together? They will repel each other. They will go away from each other. Minus, will they come together? These are like charges. They will repel each other. But if they were unlike charges, like plus, minus, they will come together. So what does this tell us? It tells us that since anodes are positive, anode electrodes are positive, it means that they will love those ions that are negative. So they will have to, these ions, which is SO4 2 minus and OH minus, will go to the anode. Are you following me? That's how it works. It's very easy. So SO4 2 minus. So on the anode, what will be the ions migrated? There are two. SO4 2 minus and also OH minus. I believe you understand how it was solved. Very easy. So moving further on the cathode, what will be the ions that will be migrated as well? Because cathodes are negative, definitely they will attract the positive guys. And from the look of things, we have, two elements here that we have the two ions to be the same, unfortunately. So definitely we'll just pick one of them. Do you understand? It's very easy. Now, There are some cases where there will be, most cases they are different. I'm still going to explain that as we progress solving the question. Because we are not done with the mechanism. What's the last? Discharge. Let us now discharge. Let us now know the one out of the ions we've picked that will be preferentially discharged, to now then write out the equation for that particular ion that was discharged, so as to get our answer. It's a watch closely. Now, first of all, let's work with the anode. Now, between SO42 minus and OH minus, which of them will be discharged? Because the one that will be discharged, because we are in the last mechanism, which is called discharge. The one that will be discharged determines what we'll get as our product in the anode. Are you understanding the point? It's very easy. And how do we know the one that will be discharged? We have to basically, they are ions. Specifically, they are negatively charged, so they are anions. So we have to basically know all of these anions and know the ones that will be discharged. I'll be using the position of these anions in what we call the electrochemical series. Are you following me? Now, there is a series that says, there's an acronym, I'm going to put it here on the screen, that says, Felice shows no concern breaking Irene's heart. So the acronym gives rise to what I'm about writing, which is Felice, F minus show, which is SO42 minus no, NO3 minus consign, CO3 2 minus breaking, BR minus Irene's, I minus, and heart, OH minus. I believe you are following me. So I'm going to put the acronym so you can match it with what we've written. It's very easy. So this is Felice show no concern. So basically, these are for the anions. So those elements that are positive also have their own cations, have their own way they are arranged in what we call the ECS, electrochemical series. So on this, how do we know the one that will be preferentially discharged? It is very, very easy. There are various factors that determines if a particular substance or ions will be preferentially discharged, and one of them is position of these anions in the electrochemical series. So the ones that are lower will be preferentially discharged. Listen, the ones that are lower, we'll be using that to solve this question. The ones that are lower will be preferentially discharged. So you compare between SO42 minus and OH, which is lower. OH minus is lower than this. So OH minus will be preferentially discharged. Do you understand? So on the anode, we know that OH minus will be preferentially discharged, will be discharged. I believe you understand how this was determined. So if you observe for cathode, it does not have any competitor. For instance, here was sodium, and like for instance, one of them was sodium. Then you still use the position. So for the positive element, the metals, the cations, for we to know them is still using understanding their electrochemical series. I'm going to put it here on the screen. It won't be like, the board. I have to manage the board to make sure that everything enters. So I won't be writing it. It will be here on the screen. For instance, it was sodium and hydrogen. So comment down the one that will be preferentially discharged. It's simple. I said that the ones that are lower will be preferentially discharged. So determine that and provide the answer in the comment section. So there is no question. So it's going to be H plus for the cathode that will be preferentially discharged as well. H plus will be preferentially discharged. I believe you understand how it was determined. It's very, very easy. Now, moving further, this must be noted. You can see we have arrived at determining the ions that will be discharged at each of these terminals, which are the cathode and as well as the anode. We've done that. So, you have to note something. It is very important to note that these terminals, which are called electrodes, which are the cathode and as well as the anode, undergo some specific type of reaction. This will help us to determine exactly the product at each of the terminals based on the way the question was asked. It is very easy. Watch closely. Now, to know the reactions that these terminals undergo, which are the cathode and anode, I'm going to use this acronym called cryo. It's very, very simple. You must understand here that this C you are looking at is the cathode, whereby A is the anode. And you must understand here that C, which is called cathode, undergoing reaction, which is called reduction. Please take note, it is very, very important. So cathode as a terminal in general undergoes reduction, whereby anode, which is A you are looking at, undergoes what we call oxidation. I believe you are following. And reduction and oxidation has different definition based on different terminologies as well, because this will help us to be able to write the correct reaction to determine our products based on the question asked. So let's bring back these terminals. So up here, I'm going to write cathode, and as well down here, I'm going to write anode. In the cathode, what was discharged? H plus, which is called hydrogen ion. In the anode, what was discharged? OH minus, which is this. You understand? Now, this must be noted about reduction and oxidation. Of using a term to define reduction and oxidation, and that terminology will be electrons. It is very important in this aspect of electrolysis. We have other terminologies used to define reduction and oxidation. Others are oxygen, hydrogen, electronegativity, and electropositivity, oxidation number as well. But you must understand here that we can also use electron number to define reduction and oxidation, because it will help us here to form the reaction to be able to know our product. Now, this must be noted. So know the definition that will be used. Now, it is very, very important we note here that in reduction, there is gain of electron. In reduction, there is what? Gain of electron, whereby in oxidation, it is the opposite. There is loss of electron. This must be noted. This electron we are looking at here is symbolized as E minus. And also this electron here is signifies as E minus. This is what we'll be imputing in our reaction to get our product. There is an acronym to actually note this, and it's called OIE. Oxidation is loss of electron. That's why here was L, whereby reduction is gain of electron. I believe you are following me. It is very, very simple. Now, let's go back to our cathode and understand the reaction to get what will be liberated at the cathode, the product for the cathode, so we'll get an answer. It's very simple. Remember, I said that for cathodes undergo reduction, and reduction is what? Gain of electron. You are gaining electron to yourself. That means this hydrogen ion will actually gain electron. Electron will be with it. You understand? If it was loss of electron, this electron will not be with the hydrogen, it will be at the product side. I believe you understand what I'm saying. It's simple. Gain of electron, the ion gains electron. So if H plus now is gaining electron, what do you think will be our product? It's simple. You can see here that because this is cathode in general undergoes reduction. So it's logical. You can see hydrogen here. So what do you think you have to put here as well? This is simply balancing of chemical reaction. Whenever hydrogen gains electron, we are going to get hydrogen gas. It is simple. It is not difficult at all, because here was hydrogen. So what should be here? Another element can be here, still hydrogen. And you must understand here that hydrogen is diatomic. For hydrogen to be written, hydrogen without the charge to be written in an equation, it should be written as in a molecular form, as H2. It's simple. If it was atomic form, it would have been H, and it doesn't work that way. So if you observe now, this reaction is not yet balanced. We have to balance it. So you can see we have two hydrogen at the right hand side at the product. So here as well should be 2. You understand? So as to balance it. And as we are doing this, the charge will increase for hydrogen. The charge will not be 2 plus. You understand? You know the charge at the end, we are cancelling these charges. So here is 2 plus. So definitely we have to put 2 in the front of this E minus as well, which is the electron. So as to make sure that the charge is balanced too. I believe you are following. It is very, very simple. So you can see at the end, in the cathode, what was the product gotten? Hydrogen gas. Hydrogen gas. So for the option A, if you observe option A, is for the cathode, you can see hydrogen. Do you understand? It can be oxygen. So let's check out for the anode, what will be at the anode. Okay, simple. So moving further for anode, we already established that anode undergoes oxidation, and oxidation is the loss of electron. So definitely, this ion we've gotten will lose electron, which means it's going to lose E minus. Are you following me? Because when you're losing, the thing is not coming to you, it's going away, it's going to the product. Do you understand? That's just simple logic. And this must be noted: whenever OH minus, which is called the hydroxide ion, is oxidized, undergoes oxidation, it gives rise to water and oxygen gas. This is something you should know because it is very, very important. It gives rise to H2O and as well as oxygen gas plus the electron that was lost. This is something you should know. It is very, very easy. I believe you are following me. It is very, very easy. So if you understand here, if you observe here very well, let's balance the reaction. So note this: whenever OH minus is to undergo oxidation because it's in the anode now, anode undergo oxidation. Note this always: OH always give rise to water and as well as oxygen gas. So we have to balance the reaction. Okay, we need to balance it. But even if we don't balance it, we'll still get the answer to the question because at the anode that you are seeing oxygen gas was liberated. It can't be solved for because sulfur was not mentioned here. Do you understand? So definitely the answer to this question is option A. You can see how easy it is. You just have to spend your time, take your time to solve this question without stress. So let's balance the reaction. Here you can see that we have 3 oxygen, 2 and 1 here. So what do? We have to put 4 in the front of this. Yes, we have to put 4 OH minus. So definitely when we do that, I'll put 2 in the front of water. Because when I put 2 in the front of water, we are going to have 4 hydrogen here. 2 times 2, that's 4 hydrogen, making this 4 to affect every single species. So we have 4 hydrogen as well, and automatically we have 4 oxygen. Because here was what? 2 oxygen, that's 4 oxygen. So definitely you can see that the ion in general is still 4 minus, 4 minus. So definitely we have to make sure that the electron is still 4. So to balance the charge is very logical. You just make sure that what you have in the ion should be the same number as your electron. That's the point. If you observe, here was 2, here was 2, here was 4, here was 4. That's simple. So I believe you understand how this question was solved. It's very, very easy. It is not difficult. And you can see how the answer was determined. So get ready for your own practice question. Okay, guys, here is your practice question. So make sure you provide the answer to this question in the comment section. It is very easy.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.